Welcome to the final question, question number 37 from the June 2014 Algebra Regents exam. A company is considering building a manufacturing plant. They determine the weekly production cost at site A is A of x equals 3x squared, while the production at site B is B of x equals 8x plus 3, where x represents the number of the number of products in hundreds, and A of x and B of x are the production costs, and that's our y-axis in this graph here. And that's also in hundreds of dollars. Graph the production cost functions on the set of axes below and label them site A and site B. Okay, now a couple different options of doing this. One is you could plug these into your graphing calculator and try to figure out some points that you could connect. What I'm going to do is I'm going to create a table of values for both of them. Let's start off with A of x. And we'll be comparing x and A of x. And A of x is 3x squared. So let's start off with x being 0. Then 3 times 0 squared is still 0. If x is 1, 3 times 1 squared is 3. X is 2. 3 times 2 squared is 3 times 4, which is 12. And then 3 times 3 squared is 3 times 9. That's 27. And then finally, if x is 4, 3 times 4 squared, that's 3 times 16. And that's 48. All right, let's go ahead and plot these points here. I'm going to have to zoom in for sure. Okay. Starting off with 0, 0. 1, 3. So 1. So we can see here it's going up by 2 on the side each time. So 2, 4, 6, 8, 10. So 1 and 3 would be about here. 2 and 12. That's here. 3 and 27. Let's see, that's 20, 22, 24, 26. So 27 is right there. And then 4 and 48 will be way up near the top here. So we can see that this is growing exponentially. So this is going to form a nice little curve, just like so. All right, now let's figure out the points for B of x. Starting off with an x value of 0, 8 times 0 plus 3 is 3. For an x value of 1, we'll do 8 times 1 plus 3, that's 11. For 2, 8 times 2 is 16. 16 plus 3 is 19. 8 times 3 is 24, plus 3 is 27. And 8 times 4 is 32, plus 3 is 35. Okay, now let's zoom in again and we'll plot these points. Okay, so 0, 3 is our first one. And then 1 and 11, 2 and 19. That's going to be right around here. 3 and 27. Oh, that's where they're going to cross each other. And then 4 and 35. And so we can see that this is increasing at a constant rate, so this should be giving us a straight line, just about like that. Great. Okay. So we've now graphed them. Oh, and don't forget, we should be labeling these. So this is B of x, and this is A of x. Okay, next part of the question. State the positive values of x for which the production costs at the two sites are equal. We can see that that happened right here, and the positive values of x is 3. And if we want to be really specific, remember that this is the number of products in the hundreds, so this represents 300 products. And it does say as well explain how you determined your answer. We can say that this is based on where the two graphs intersect. So where they intersect is how we found that x value. Now, for the last question, if the company plans on manufacturing 200 products per week, which site should they use? Because obviously, we want the cost that they're spending to be as little as possible. We can see that if we look at 200 products, that's right here, we can see that the purple graph, that's A of x, has a lower cost compared to the B of x graph. That means that we should be using site A, because that's the function A of x, and that's because the cost is lower than site B. And that's because we're comparing the y values here, that it's less. Okay, that's a pretty involved question. Hopefully that was helpful. And thanks for visiting JD's Regions Preparation.